H2K Infosys provides world-class online IT training, staffing and software testing solutions to customers worldwide. H2K Infosys supports 100% job-oriented training, hands-on project work, cloud test lab, resume preparation and review, mock interviews, robust syllabus. One-time pay, lifetime access to live classes and videos. H2K Infosys has won the trust of thousands of students worldwide. For free demo class, visit h2kinfosys.com.
1,1,1,1,1,1, so on. So now are you able to understand this? After my shuffle and sort, the reducer will collect all the outputs from my mapper and it will generate the key value pairs in some other form. So some collection of values have been happening for each of the key. So my club key is having or is collecting all the keys of it. So maybe mapper 1 is throwing three key value pairs such as club, 1, club, 1 and club, 1, and mapper 2 is generating 4 key value pairs for club key. That means club, 1, club, 1, club, 1, club, 1, and the same way happens it for mapper 3 and mapper 4. And after all these outputs have been generated, shuffle and sort phase, which is an inbuilt phase, or even we can have some control on it as well. But if you take the inbuilt form itself, the output would be in the form of key value pair again, which will be in the form of club, 1, 1, 1, 1, 1, which is repeated 13 times because my input is having 13 cards for club, right? So after this is finished, my reducer will give the output . So this is what my reducer. So my reducer's action is just aggregation. So it will see what are the independent keys that were available till now. So there were 4 keys finally that was submitted to reducer. So it will see the key and then it will think of all the values that were available for it. So it will see like there were 13 ones that were available. So finally it will aggregate all these ones and it will generate as club, 13, spade, 13, heart, 13 and diamond, 13. But what happens with this shuffle and sort, how it is going to produce all these outputs, and what if the case I'm having more than one reducer, and all those things we will discuss. Okay, but right now just understand the straightforward and the simpler way. So anyone has any questions on this, or can I go ahead? Okay, cool. Okay, so if you see my reduce here, it is having the key, the same list of K2 here that is given to K2 here as well, but here it is having the list of all values that is related to that particular K2 key. So it is having all the list of values that is related to a particular club key. And finally, reducer is giving the final output as K3, V3. So this is what K3, V3, club, 13. So now let's talk something about input splits as well. Okay. This is a new term which we haven't heard till now, right? Because till now what we all know is there will be some input data that it will be divided into chunks of blocks, and these blocks will be stored into our HDFS blocks. So that is what our physical division is. How the blocks will be getting stored in HDFS, what the replication factor, all those things. Okay, we are aware of it, but still we just know about this physical division. But once this Mapreduce concept comes into picture, in the sense once the processing starts, there will be some, one second. Okay, sorry. Okay, there will be some intermediate or internal logic in our framework such that the input data is being divided into input splits, and these input splits will be actually given as input to our mapper function. So our mapper function will not read these blocks. It can understand only the input splits. A block and split is nothing but almost it will be having of the same size, but if you think in some other way, a block is just a kind of physical division, whereas the input split is a kind of logical division. So there is something called as input format, and this particular input format is responsible for creating the input splits. So once if any input file is given to job tracker, the job tracker will go back to this input format, and it will ask them to create the required input splits for that particular file or block. So once the input splits are available, it will count like how many splits totally I have, and such that I can give these input splits to my mapper. So for example, if that functionality has generated 4 input splits, then job tracker will decide like, okay, I got 4 input split for this particular amount of chunk of data. So I have to create 4 mapper tasks such that each mapper task will read this input split. So an input format is just responsible. Let me write it. Okay, so if you read this, an input format is responsible for creating the input splits, but still these input splits are not having, or it doesn't hold the actual data. Okay, so it is just like a reference to your actual block. So it will tell you like, okay, read this block from this position to this position only and process it only to this area. And then the next mapper task will read from the next position to until some other next position. It doesn't go with block by block, but still the framework or the input format will try its best such that the whole 64 MB of block will come under a single split. So it will try its best to make that input split as best as possible such that the block size and the input size will be almost same. It will hold almost same. So if you see this diagram, you will understand much more clearer. So there is some record or some text of a line that is given in my input file. So if you consider this, I am having block boundaries till here. So I am having 1, 2, 3 and 4. So totally 1 block, 2 and then some part of another block, that is totally 3 blocks I am having. But if you read it in the form of records, my first block boundary, so my first block boundary is ending somewhere in between the record itself. It's not reading the total 5th record, right? So it is somewhere losing some information. So that is the reason a new concept have been introduced called as input splits. So what this input split will do is it will read till the 5th end of block, that is to this position, and it will give the same value to the first mapper. So it will think like once it reaches this block boundary, it will see that the block have been finished, but still the record haven't been finished. So what it does is it will store the memory location till the end of the 5th record at one position, and it will give all these inputs to the mapper task. So what my mapper task does is it will read from the record 1 to end of record 5, and it will process the whole data. And again, now another map will come here again. Let me take my screen snap here. So from here to here, my mapper 1 executes. Okay, let it be. Again here to here, mapper 2 executes. Mapper 3 and so on. This is what actually happens internally. So the reason why it is trying its best to make the block boundary very nearer to the input split is, okay, can anyone give me a quick guess on it, why we are trying our best to have the same block boundary and as well with the same input split end also? Any reason?
Is it because to minimize transfer of data between nodes?
Perfect, exactly.
For the remaining records?
Right, you are perfect, yeah. That is the reason, because it has to transfer the data internally. For example, if you see my mapper 1, this whole block boundary, the first block boundary, will stay on one machine itself. That is not divided into different machines, right? So the whole block will be divided into single machine 1 only. So what this map task will try is, or what our framework will try our best is, it will see that there is no maximum of data transfer between machines. So it will try its best to make the block size as 64 MB, and the whole 64 MB will be going into one single map itself. But if any case that if that is not possible, there is no other option, it has to move the data. So some data movement will be there definitely internally. So what happens is, okay, let's drop it here. We can discuss much more. Okay, once the split is calculated, the client sends to the job tracker, and using this storage locations, the job tracker will assign the map tasks to run it in the corresponding task trackers. So that is what actually happens. So if I take a new program or maybe some other, so let's see how the data movement happens or something. Okay, imagine this is your laptop or client. Okay, now this is my whole cluster. On your laptop, you will write a program, right? So you have some program with you. And it will be converted into jar file, right? So once you write your program, you will export all your data into the form of a jar, right? So we had seen that in our HDFS readings and writings as well. So what we did is we have converted into a jar file. The whole program is converted into jar file, and then only we can execute that program in our terminals. So the whole program is converted into a jar file. But if you take this in our Mapreduces, the whole jar file will contain there is some mapper class, and there is some reducer class, and again to run this there will be one more main class. So these are the three classes or three programs that I will write independently, and I will club all these things into a single jar file, and that jar file is my program.jar file. Now I will give this program.jar file as an input to my job tracker, right? Because job tracker is the guy, or he is the